All right, happy Monday, everyone. Unfortunately, I can't be there with you today for this last section of notes. Fortunately, it's a pretty easy one. We're going to be talking about best method as well as writing equations. This will be our last section before we start getting ready for that test, which is going to be on block day this week. So make sure that you are staying caught up with homework. Make sure you're looking over that quiz that we took last week. And then I'll be there on Tuesday, tomorrow, to go over any questions with you and help you start reviewing. So let's just jump straight into this. For each of the following quadratic equations, we're going to decide which of the four methods that we've looked at would be the most efficient and then explain our reasoning. Now, we're looking for most efficient, not just your favorite. So don't think the best method is just whichever one you like best. It's the one that should be the quickest for you to use. Now for methods, I've got these in order of which ones are usually fastest. Factoring is usually number one, square roots is usually the second quickest, completing the squares is usually the third, depending on what type of equation you've got, and quadratic formula is kind of usually a last resort. In other words, none of the other methods worked. So what we're going to be looking at today is kind of the reasoning as far as why you would choose each method. Let's start with factor, and let's see if we can factor on number one. So number one, we've got 5x squared plus 20 equals 4. Now we're not going to actually solve this, but let's at least get it equal to 0. So let's subtract 4 from each side. And at this point, we've got 5x squared plus 16 equals 0. So in terms of factoring, if you only have two terms, which is what we have here, there's really only two methods of factoring we've seen for that. One is greatest common factors, which if you look at this particular problem, there is no GCF, so that's not going to be helpful. The second was difference of squares. And in this case, although 16 is a perfect squared, as is x squared, 5 is not a perfect square. So factoring is not going to work. So for part of our reasoning, we're going to say that this is not factorable. So let's go on to option 2, which is solving by square roots. Now, remember, for solving by square roots, there cannot be a middle term. And in this case, there's not. It's just 5x squared plus 16. In fact, you can probably think about how you'd use square roots to solve. You'd subtract the 16 over, you'd divide by 5, you'd take the square root of x squared, and then you're already ready to solve. So our best method, our most efficient method, is going to have to be square roots. And so for our reasoning, in addition to it not being factorable, the reason why we would pick to use square roots is that there was no middle term.
Frank's Club is selling crepes this morning at $1.18 for $3.
For number 2, we've got x squared plus 10x plus 21 equals 0. So as far as methods, again, we want to always start by trying to see if it's factorable. So if we were to think about, is this factorable, setting up our two parentheses, we'd be looking to get x squared by taking x multiplied by x. To get 21, we need numbers that multiply to be 21, add to be 10. Pretty quick to find out, 7 and 3 would work. And actually, we're already pretty much done solving. We can already say the answers are -7 and -3. Really, for factoring, only reasoning you need to give is that it's factorable. Because if it's factorable, that's the most efficient method. We're going to go ahead and use that. Okay, so let's take a look at number 3. So on number 3, we've got 5 equals x squared plus 8x. Again, we want for one side to equal 0 no matter which method we would like to solve with. So I'm just going to subtract the 5 over. And let's see if we can't factor this one first. So to get x squared, x and x. To get a -5, we'd have to use 5 and 1, which when you think about adding this together, you're going to get 5x and 1x is 6x. There's no possible way to use that to get 8x in the middle. So factoring, not going to work. It's not factorable. Also, thinking back to our reasoning on number 1 for using square roots, we said on number 1 that there was no middle term. The problem is, with this problem, as you can probably tell, there is a middle term. There's 8x in the middle. So we're not going to be able to use square roots either. And again, for the reasoning, we would just have to say that it has a middle term. Alright, so now let's talk difference between completing the square and quadratic formula. For completing the square, if you think about where that worked nicely, that was any time your middle number was an even number, because it could divide evenly by 2. Remember, if it was an odd number, you end up having to deal with some fractions. But for this one, completing the square actually wouldn't be too bad. you'd have 8x plus blank minus 5 minus blank, and then for filling in our parentheses, half of 8 would be 4, 4 squared would be 16, and just like that, we've already completed the square. So yeah, for this one, completing the square would definitely be the most efficient method, and for reasoning, we've already said that it's not factorable and that it has a middle term. The only other thing we need to say is that the middle term was an even number. And that would be our reasoning for picking completing the square. Okay, last one. Here we go for number 4. So for methods, if you think about factoring for this one, you've got to make 3x and x, but the numbers that multiply to be negative 74 also add to be negative 5. It's not going to happen. I'll just let you know right now, not going to be factorable. Second thing, with square roots, notice that there is a middle term, so we're not going to be able to use square roots. So far, we've already decided that this is not factorable, that it has a middle term. Now let's check to see if we can use completing the square. Now, first thing with completing the square is we've got a number in front of x squared, so we're going to have to factor that number out first. And already, I hope that you can probably tell that completing the square ... is probably not going to be our best method, because not only is our middle term not an even number, but it's already a fraction once we've done that. So completing the square, middle term was not even, and so then with quadratic formula, unfortunately there are some pretty big numbers there, but that's about the only thing that's going to make this problem work. Which for reasoning, I really don't need you to give me any extra reasoning. You've already said that factoring didn't work, that square roots didn't work, that your middle term was not even, so completing the square didn't work. At that point, we've already decided that quadratic formula is our last resort. You don't need to give me any other explanation than that. Alright, so that's best method. And guys, that's going to be important because on the test on block day this week, there's going to be probably about 7 or 8 problems where I tell you how I want you to solve. Either solve by square roots, by factoring, completing the square, or quadratic formula. But then there's probably going to be another 5 to 6 problems where it just says solve. And for those problems, it's going to be in your best interest to solve them in the most efficient way. Because even though it's a block day for a test, you're still going to be limited by time. And you're going to need to know how to do those problems and use the most efficient method and not just use quadratic formula every single time. Alright, one last thing that I'm going to show you guys, which is most likely not going to show up in the test. In fact, there's not even homework on this, but I just want to show you kind of what happens if you have complex solutions as your, or complex numbers as your solutions. So given each pair of complex solutions, we're going to work to write a quadratic equation in factored form first, using the 2 complex solutions. I'm going to do number 5 with you guys. Number 6 is one for you guys to try on your own later if you'd like to. So for factored form, remember that that's just taking the opposite of each of those values. In other words, subtracting by those, so x minus in parentheses 2 plus 3i, and then x minus in parentheses 2 minus 3i. Now if you want to simplify that, you're more than welcome to. You just have x minus 2 minus 3i. For the first parentheses, that would be just distributing the minus sign across. Same thing for the second one. If you distribute the minus sign across, you get x minus 2 plus 3i. So that would be your factored form if you wanted factored form using those 2 complex solutions. However, what I want us to also do is multiply these out to rewrite our equation in standard form, because there's something I want to show you that happens. So x minus 2 minus 3i, and then x minus 2 plus 3i. And there's going to be a lot of distributing that happens just now. So let's take this piece by piece. Starting with x. X multiplied by x is x squared. X multiplied by negative 2 is a minus 2x. And then x multiplied by 3i is a plus 3ix. So that's round 1. Now let's go through and distribute that negative 2. So negative 2 multiplied by x is a negative 2x. Negative 2 multiplied by negative 2 is a positive 4. And negative 2 multiplied by 3i is a negative 6i. Alright, that was round 3. Or round 2. Here comes round 3. So let's take our negative 3i and distribute it as well. So negative 3i multiplied by x is a minus 3ix. Negative 3i multiplied by negative 2 is a plus 6i. And then negative 3i multiplied by 3i is a negative 9i squared. Okay, finally done multiplying it out. Let's go through and let's simplify. We only have 1x squared, so we're already done with this term. For terms that have just x in them, we have negative 2x, and negative 2x is a minus 4x. Now, we also have a plus 3ix and a minus 3ix that are going to add to be 0. In the same way, minus 6i plus 6i add to be 0. So then in terms of just plain old numbers, we've got a plus 4 here. We also have a minus 9i squared here, which remember I squared will change that from being a minus 9 to a plus 9. And then when we simplify that, we get x squared minus 4x plus 13. So what do you notice about the standard form equation above, and how do the coefficients compare to the roots? What I hope that you notice is that the coefficients are all real numbers. I'm just going to put that using that special symbol for real numbers. So those are all real numbers. The roots, however, are complex numbers. And the way we can say complex numbers in the same way is a C with an extra line through it. So even if you have complex numbers as your solutions, you can still have real number coefficients. In fact, everything we've looked at, if you've noticed, has all been real number coefficients. All right, that's actually all I've got for us today. Pretty short day of notes. If you want to practice that again, take a look at number 6 there. Just an extra practice problem, very similar to number 5. There is homework on big ideas. Your review should also be posted with an answer key. So once you're done working through homework, feel free to get started on the review, because we're only going to have one review day. And in that one review day, we're going to have to go over questions from the notes, questions from 2 homework assignments, as well as the review questions. So if you don't get anything done before Tuesday, you're going to have a lot of studying to do on your own at home that night. That being said, guys, I will be back tomorrow. Can't wait to be back. It's been a long 4 days here for me, and I will see you then.